Hello, ladies and gentlemen. We are going to be talking today about similar triangles, just like we have been in the past, but more specifically, theorems for similar triangles. So just like we had theorems for congruent triangles, like remember angle, 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 side angles, all of those, we're going to talk about, though we have three theorems like that for similar triangles. So determining how do I know that triangles are similar. We're going to need our green foldable notes calculator if you want, and a pen or pencil. These are the notes that we are going to be using today. This is the foldable that I'm referencing that I want you to glue into your notes, whether you want to do that before or after. Either way, under each of these flaps, we're going to be doing example problems in the video. So if you want, you can glue this in, and I think you'll have to glue it in a little bit sideways in order to fit into your notebook. Okay, so our first theorem in similarity in triangles is the angle-angle similarity postulate. And this is our first flap on the left of our little foldable, the angle-angle similarity. You do not need to write this definition down. It's already on and typed on the front of your notes, so you do not need to write this slide down. We are saying that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So in this image, we are saying that angle R and angle V are congruent because they both are 45-degree angles. And then we're also saying that these two green angles are vertical angles, so we know that they're congruent. So that means that we have two congruent pairs of angles between two triangles. So therefore, we know that triangle WRS is similar to triangle BVS. And remember, just like with congruent statements, the order of this does matter. The order does matter here. Okay, so if we open the angle-angle similarity flap, we'll get these two examples, and we're determining if the two examples below or the two triangles below are similar by the angle-angle similarity postulate or theorem. And if they are, then we need to write our similar statement. So in our first example, they're telling us that we have angle A equal to 75 degrees, which is congruent to angle D because that's also 75 degrees. And angle C is congruent to angle F because they both measure 31 degrees. So we do have two pairs of corresponding angles that are congruent. So yes, these two triangles are congruent. And so we have to write our similarity statement. Triangle ABC is similar to triangle. And if I said ABC, now I have to say DEF. I have to write it in the same order as the corresponding angles. So looking at number 2, we know that V and Y are congruent by the hash marks given to us, and we also know that this angle and this angle are congruent by vertical angles. So even though we don't know the measurements of these two pairs of angles, we do have two pairs of angles congruent to each other. So that means that these two triangles are similar, so we need to write a similar statement. So triangle WVX is similar to triangle ZYX. So you do not need to write this slide, and let's open up our middle flap, or I guess this is the front of your middle flap, the side, side, side similarity theorem. This theorem states that if the corresponding sides or all three pairs of sides of the two triangles are proportional, then the triangles are similar. So you do not need to write this down. We're just thinking this through. In these two images, triangle ABC and QRS, if we're trying to determine if these two triangles are congruent, or sorry, similar, not congruent, similar, then we need to think to ourselves, is 3/5 equal to, is that ratio equal to 4/20? And is 4/20 equal to 6/30? Well, let's reduce all of these ratios. 3/15 is the same thing as 1/5. 4/20 is the same thing as 1/5. And 6/30 is the same thing as 1/5 if we just reduce those fractions. So they are all 1/5 is equal to itself. So all three sides are proportional. So that means that triangle ABC is similar to triangle QRS because of the SSS postulate or theorem. And that also means that our scale factor would be 1 to 5. Again, you did not need to write this portion in your notes. This slide, however, we should write in our notes, and we should open up our middle flap for our examples 3 and 4. We're determining if the examples below are similar by the side, side, side similarity theorem, and if they are, then we need to write a similarity statement. So we need to determine if 3 over 6 is equal to 4 over 8, and if that's also equal to 5 over 10. All I'm doing when I'm setting up these proportions or this string of proportions is I'm doing short leg over short leg, long leg over long leg, and hypotenuse over hypotenuse. So the three corresponding parts, we're putting the smaller triangle over the larger triangle or the larger triangle over the smaller triangle. And I have to do that to see if they're similar. There's no other way I can set that up. Okay, so if we were to reduce all these fractions, 3, 6, 4 eighths, and 5 tenths, well, that's all just 1/2, so our scale factor is 1 to 2. So these two triangles are similar, yes, and we need to write our statement now. So triangle QPR is similar to triangle TSU. Okay, so going down to number 4, we need to set up our three fractions or our three ratios. I'm going to start with this side, 30 over 24. So 30 over 24, is that equal to 32 over 25? This side and this side correspond to each other, and is that also equal to 35 over 28? If we were to reduce these fractions, we would get 5 over 6, and then we cannot reduce 32 over 25, so this is not equal to, and then if we were to reduce 35 over 28, we would get 5 over 4. So none of them are even the same ratio, so these triangles are not similar. Okay, so for our last flap, let's flip to the front for the side angle side similarity theorem. And again, you do not need to write this down. This is on your front flap. If an angle of one triangle is congruent to an angle of a second triangle, and the sides, including the angle, are proportional, then the triangles are similar. So what they're saying is if we have an angle, and in this example, it would be C and T, they both measure 32 degrees. And if we had two sides that are on either side of that angle, so the angle would be sandwiched between those two sides, we need to see if those two sides are proportional. So we need to ask ourselves, is 16 over 12, is that fraction equal to 28 over 21? Well, if we reduce 16 over 12, we can take a 4 out of both, right? So 4, that leaves me with 4 over 3 if I reduce the fraction. And with 28 over 21, we can take a 7 out of both. 28 divided by 7 is 4, and 21 divided by 7 is also 3. So those two things are equal to each other, and so our two triangles would be similar. Triangle TEA is similar to triangle CUP, where triangle T is similar to triangle CUP because of the side angle side postulate. And we just also note that our scale factor is 4 to 3. So all we need to do for the side angle side is set up two ratios equal to each other. So we just need one equal sign in our proportion. Whereas with the side, we needed to set up three ratios. Okay, so we should be able to grab our pencils back out and flip open to numbers 5 and 6 under the side angle side similarity flap. And we're doing the same thing, determining if the two triangles are similar, and if yes, writing a statement. So we have angle K congruent to angle N, and that's our included angle. And then we have two pairs of sides on either side of the angle in both triangles. So we need to set up our proportion from those two sides. So we're saying 8 over 6, because these two sides correspond to each other, right? Is that equal to 20 over 15? If we were to reduce 8 over 6, we would get 4 to 3. And if we reduce 20 over 15, we would get 4 to 3. So in both cases, our scale factor is 4 to 3. So yes, these two triangles are similar. So now I need to write my statement. So triangle JKL is similar to triangle MNP. So looking at number 6, we have triangle ADE, which is a smaller triangle, embedded in the big triangle ABC. So that means that angle A is going to be congruent to itself, and the sides on either side of the angle are 15 and 25, for 15 for the small triangle, 25 for the big triangle, 12 for the small triangle, and 21 for the big triangle. So how I'm going to set up this proportion is 25 over 15. So I'm going big triangle to small triangle on the same side or corresponding sides. And then I need to do big to small again. So 21 over 12. If we take a 5 out of 25 and 15, that gets us 5 over 3. If we take a 3, I think is what the GCF is between 21 and 12, that gives me 7 over 4. So were these two things congruent? No, they weren't. 5/3 is not the same thing as 7/4. So therefore, these two triangles are not similar. I want to thank you guys for taking good notes, and I will see you tomorrow.